How you doing, everyone? Greetings and welcome back to the basement. Take a listen to this. What do you think of that? This thing is playing audio, my own audio that I made. I'm able to slow it down, speed it up, and even play it backwards. Listen. That's backwards. I'm amazed by this stuff. This stuff is amazing me more and more every time I sit in front of it and fool around with it. Over the space of the last 2 months, I've been kind of screwing around with digital audio, and I've been using a modern day computer, granted, to record the audio files, but then I've been trying to get them to play back on 8-bit computers with very little modification. And I managed to get my Coco 2 to play a sound file I made in the last episode, but I was kind of piggybacking it off an existing game, Nick Morante's Donut Dilemma, which has a little bit of digital audio featured in the intro of that game. All I did was I hacked in my audio instead of that original audio file and got it to play. But for today's episode, what I wanted to do was to write my own code. And that's it running there on the Coco. So what we will do is we will step back a little bit and just let me explain to you how I wrote this code and kind of how it works. I got 2 cameras set up here, the regular one and my webcam. And I've got my assembly language code opened up in front of me in Notepad++. I've set to all different colors and whatnot to try and better explain what the hell is going on. But it's a simple enough little program that I've written. It's only about 17 or 18 lines long, and there's not a whole lot going on in it, so I'll try and explain it as best I can. But just before I begin, let me say that when I wrote this sound player, there was a choice available to me. I could write it the way anybody would write one. So a kind of a sound player that would let you load up any sound file you wanted and play it. But I decided not to do it that way because it seemed a little bit kind of complicated to me. So what I did instead, just to make the process a little bit easier, was I wrote a sound player that had one sound file integrated into it. So it's kind of standalone. It'll only ever play the one sound file that I've put into it, and that's it. But so what I did was I recorded in Audacity my little sound file, help I'm stuck in here, or whatever it is, and I saved it out as help I'm stuck in here.raw, the way I did the feckin' donuts file in the last video, as 8-bit unsigned PCM with no header. So that's what I did. And what I did was I made it available to the compiler when I was compiling this code. So let me just say that assembly language is written in what's called human readable form. So what we've got is, we've got text here on screen that we can kind of understand, likes of org, LDX, LDA, STA. They kind of all mean something, load A, store A, all that kind of thing. So we write it this way, in a way we can understand easily enough, and then we pass it through a compiler, which will turn it into machine language that the computer can understand quite easily, but is a lot more difficult for us to understand. So we need to keep in mind when we're writing our assembly language code that we're going to be passing it through a compiler. And we can give commands to the compiler to tell it to make the machine code in a certain way. And a prime example of that is this org directive here. Now, any of the commands in which you're speaking to the compiler and not to the PC or to the CPU of the target computer are what we call directives. So here what I'm doing is I'm passing an org directive. I'm saying org string 3000, which means that I want this program to be loaded to, or I want it to originate at hex address 3000 in the color computer's memory. And the reason I want to do that is that I know that at hex address 3000 there's nothing I can overwrite or feck up, more or less, by loading my code there that'll cause the computer to crash or not work the way I want it to. So you need to keep in mind when you're writing assembly language programs that you are pretty much God. If a program doesn't work in assembly, it's your fault. That's basically what it comes down to. Because anything you tell the program to do, it will do. There's no safeguards, there's no nothing like that. If it doesn't work, it's your fault. Anyway, org string 3000 will ensure that our code, when loaded to the Coco, will go to hex address 3000. Now, over here on the left-hand side of the screen, you will see that I've got a few little pieces of text. I've got play, I've got wait, and more down here. I've got end program, sound start, and sound end. And these are called labels. And they're used in assembly language programs to jump back to a portion of code to play through it again. And you could think of them very much like line numbers in BASIC. So if you were writing a Hello World program in BASIC, for example, you would do 10 print hello world, 20 go to 10. So every time it gets line 20 to print hello world again, it'll jump back to 10. So it knows to go back there and print hello world. These labels are pretty much the same. In assembly language programming, we check for conditions, and if a condition is met, then we branch to a label in order to run through a piece of code again. So that's pretty much what's going on here. I've got a couple of labels on the left hand side of the screen. Then, like I say, any of the commands here, org is a directive, as I said, and down here we have ldx, which is load x, lda, sta. These are mnemonics, or they are 6809 assembly language codes that the CPU of our computer can understand. So here we have load x, which means to load a value to the x register, load a value to the a register, store a, to store a value from the a register somewhere. That's pretty much what that stuff means. But you see here, the very first thing I am doing is I am saying load x sound start. What the heck does that mean? Well, if we scroll down here, you'll see that sound start is a label as well. And what actually happens is when the compiler compiles this code into machine language, it puts a memory address to each of these labels. So what it's basically doing here is it's loading X with whatever memory address it has assigned to sound start. And at that memory address, it will have the beginnings of my letmeout.raw file, because I've used the include bin directive to insert that into my code. You remember I said I could have made this program in such a way that I could load a file externally and play any file I wanted, but I decided that I would just kind of integrate it all into one as a standalone player. Well, that's what I've done here. At sound start, whatever memory address the compiler sees fit to put on sound start, it'll start loading letmeout.raw. So what'll happen here is X will be loaded with the very first byte of letmeout.raw. That's what's going to happen here. And then what we're going to do is we're going to load A with 3F, and we're going to store that 3F that's in A by storing A to FF23. Now, you don't need to worry how this works exactly, but basically what that will do is it will enable sound on the Coco. So the Coco starts off with its sound turned off. When we load 3F, or when we store 3F to FF23, it'll turn on sound on the Coco. That's what these two lines here do. Now what we're going to do, that we finished with this value in A, we're going to store whatever is in X. So at the moment, the very first byte of our sound file, we're going to store it into A. That's what's happening here. Load A with X. And the plus here means to move X on one space, so that the next time we come back to it, it'll load the second sound byte, and then the third sound byte, and the fourth sound byte. That's what's happening there. Then what's happening is, before we do anything with this value we have in A, it's going to check and see that what it had in X, how it relates to sound end. Because sound end, you'll notice here, is a label after this letmeout.raw file has been loaded into memory. So at sound start, we have the very first byte of letmeout.raw. It'll load in all of that file. It takes up, like, I think it's about 13 kilobytes or something. And then after that 13 kilobytes, it will kind of remember the memory address sound end. And it is comparing here to see if we've gotten to the end of that file, if that makes sense to you. If what's in X is equal to this sound end memory address, then it will branch, see here, branch if equal to end program. And end program is RTS, which stands for return to subroutine, or to pop us back into basic, more or less. That's what that does. So here what we're doing is we're loading a byte from our sound file so that we're ready to play it. We're putting it into the A register. But before we do anything with it, we're just checking to see if we've gotten to the end of the sound file or not. Is there any point in playing this? Is it part of the sound file? That's more or less what these 3 lines here are doing. This section here, what we're doing is this one line here and A with this binary value here, what it's doing is it's in a very crude way converting from 8-bit to 6-bit, because the value that we saved out in Audacity is, well, the file we saved out is composed of 8-bit bytes, and the Coco has a 6-bit digital to analog converter. So we convert it down to 6 bits just by negating bit 0 and bit 1. That's what this will do. Whatever the value is in the A register, it'll pretty much knock off bit 0 and bit 1. It'll turn them to zeros, and then it'll just pass these 6 bits, well, the 6 higher bits of the value in A to the digital to analog converter, if that makes sense to you. Anyway, don't worry about it too much. What this line is basically doing is it's converting from 8-bit to 6-bit, and then the value that's in A is stored to FF20, and FF20 just happens to be the digital to analog converter, which means that that sound will be played, or that minuscule portion of sound will be played, because pretty much 8,000 of these bytes, of this will be done 8,000 times, this portion of code here, before we get through 1 second of audio. So that's basically what's happening. For 1 second of audio, this portion of code will be run through 8,000 times. Now, in order to speed up or slow down our audio, what we're doing is we're taking the B register inside of the processor and we're loading into it the value 17. And this makes a little counter that'll count from 17 to 0 before it does anything else. And the way it works is we load B with 17. We've got a label here that says wait. And then what we do is we decrement B. So we go from 17 to 16. And this B and E stands for branch if not equal, which equally means branch if not 0. If the value in B isn't 0, it'll branch back to wait. So it was 16, it'll decrement it to 15. Is it 0? No, it'll branch back to wait. It'll decrement it again down to 14. Is it 0? No. And it keeps going on until it gets to 0, and then it checks. Is it 0? Yeah, it is this time. Well, then it goes down and it branches to play. So it goes back up here and it goes through with the next byte. And like I say, this whole section here will be gone through 8,000 times per second until our entire file has finished playing. And like we saw up above, when our file has finished playing, it'll go down to our RTS here, and that is pretty much that. That is the code that we have here. Yep. And at the very end here, what we have is an end string 3000, which is like our org string 3000, but end string 3000 down here means that start executing our code from memory address 3000. So when this is loaded in and we type exec, it'll jump to memory address 3000 and start executing this code for us. And that is the core of what makes our sound play. Now, then I did a more advanced one that is pretty much exactly the same code, but I'll go through this really quickly for you. What we're doing here is, again, we're starting at, or our origin point is 3000 hex. This will be loaded in at the same point in memory. I've set up a little speed, what do you call it, a variable. Set up a speed variable at memory address 00, and I've loaded into it 10. So basically what happens is that is our rate of speed. What we're saving into B as 17 before is initially saved into B at 10 here. And that's how it calculates the speed it will play back our code at. Later on we've got a speed up label here. And if we decide by pressing 1 that we want to speed up the rate of play, it'll load the value that's in speed, it'll decrement it, store it back, and then it'll jump to the play routine. So basically we're starting at 10, it'll decrement it to 9, save it back. So now our speed contains 9 and it'll play it, put 9 into our B register every time as our countdown. And that's how we speed up and we slow down. Pretty much, as I called it, speed down here is the one to slow it down. We're incrementing the value in that variable. That's basically the way that works. Play full is, again, what I've just shown you. This is exactly the same piece of code that I just showed you right here, loading sound start. We are setting up the play sound on our Coco. We're loading A with the first byte of sound start. We're seeing, have we gotten to the end of the file? If we have, in this case, we're going back to menu. And we're doing our 8-bit to 6-bit conversion, storing it to the DAC, going down to checking what's in speed to load it to B, and then we're going through our decrementing and waiting until it gets to 0 to go back to play and go through again. Now this little menu one is one at the very beginning of the code, and what it does is it jumps to a point in Coco's memory, which is like a keyboard routine. We'll check for a key press, and what happens is it will load a value to A for any key that's been pressed, and then we'll come back. And when it comes back, we can test to see what the value in A is. And depending on what it is, it will jump to a different point in memory. So here I've got, it will just play the sound file if I press space. So it'll jump to a point in memory. It will check at that point in memory for a key press. And if it comes back with the value 20 in A, it means space has been pressed. And then it will jump to play full and play our sound file. If 1 has been pressed, it'll go speed up. If 2 has been pressed, it'll go speed down. If 3 has been pressed, it'll play the reverse way of playing the sound, which is actually the exact same thing as I just went through with you. But the difference is that we start, instead of starting at sound start, we start at sound end. And when we get to seeing if we finished playing the sound file or not, instead of checking to see if X is the same as sound end, we check to see is it the same as sound start, because we're going backwards. We're going from the end to the beginning. And the only other difference is instead of incrementing X each time that we take a byte from it, we decrement X each time we take a byte from it, to go backwards through the bytes instead of forwards. And that is pretty much the code as it is. And just before I had an awful lot of trouble including my sound binary into my code. So just want to say huge thanks to Dave from Coco Town for that. He recommended to me, he said, why don't you try using include bin? And I did, and it worked great. So I'm sure it's common knowledge, but for someone like me who is just trying to figure this stuff out, you saved me a lot of time, Dave. Thanks for that.
Let me out, I'm stuck in here. Let me out, I'm stuck in here.
I never get tired of fooling around with this, I swear. I find it amazing that an 8-bit computer, a crude thing from years ago, is able to play sound files with such fidelity. Keeping in mind that it doesn't have like a dedicated sound chip, just a digital to analog converter that was kind of more or less intended to be used with joysticks. Which kind of leads in nice to the next episode, because what I'm planning to do in the next episode is to build up a little joystick to microphone adapter. And what I hope to do is to write a little piece of code that will actually allow me to record sound files directly into the Coco's memory, and maybe we'll be able to save them out to disk and play them back in this same way and all the rest. But this project actually started as me just wanting to insert a little piece of digitized sound into Bob and the Alien Fireflies, and I fell down this huge rabbit hole, but I am kind of glad I did, because it's turned out to be a lot of fun. And to be honest, I hope you guys are kind of enjoying this as much too. But anyway, until the next episode, take good care of yourselves, and we'll talk to you all, whenever the next episode comes around. Talk to you soon. And until then, you're staying exactly where the hell you are.